Alright, so question number 1 for the sample midterm. We're trying to price a bond. When you price a bond, you have N equals payment equals future value equals, this is the payout rule. Then here we have our interest rate, which will be our yield to maturity. We put all this in, press the present value key, that will give us price. So set it up like this every time before you touch your calculator. It's a treasury bond. Because it's a treasury bond, we know that it's semi-annual pay, because all treasury bonds are semi-annual pay. 15 years maturity means it's got 30 payments. We assume $1,000 par value just in general in this class, unless I tell you something different. The coupon rate is 8%, so 8% of 1,000 is 80. But it pays twice a year, so $40 twice a year is a total of 80. It has a yield to maturity of 8.2%, but that's an annual yield, so I divide that by 2, which is 4.1. So note, N is in semi-annual periods, the payment is semi-annual, the yield maturity there is semi-annual, so the price is $982.92. Okay, then question number 2. We have a bond again, but we're trying to find the yield to maturity, so we need N equals payment equals future value equals, this is a payout rule that's set by the firm. Present value is a price. I plug that in, I solve for IY, and IY is going to be my semi-annual yield to maturity. Verizon is issued a 20-year bond. I should have said it pays semi-annually, but almost all bonds do. So make that assumption when in doubt. 20 years maturity, that's 40 total payments, 6% coupon, 6% of 1,000 is 30, is 60, divided by 2, that's 30, take $1,000, and it says 99% of par, so for this question you could have assumed par was 100 or 17 or any number you wanted to, and just done it in percentages, but it's easiest to do 1,000. So the price of the bond is $990, but you have to make it negative for the calculator to recognize, hey, you're paying the price today and you're receiving these cash flows in the future. Or conversely, you can make payment in future value negative and present value positive. It would still work, but it's easiest just to make present value negative. So this comes out to be 3.0435 or something like that. I didn't write down this step, but when you multiply it by 2 to find the yield to maturity, you multiply this by 2 and it comes out to be 6.087 when it's rounded off. Okay, so let's look at number 3. We need to consider information in number 2. The City of Atlanta. So City of Atlanta, we're going to assume that all muni bonds are tax exempt, even though that's not always true. We're just going to assume that here. So the yield I want on a muni bond is equal to the yield on my taxable corporate times 1 minus the tax rate. The yield on that taxable corporate is 0.06087 multiplied by 1 minus my tax rate of 40%. This means, I didn't write this number down, hang on just a second. Okay, so this comes out to be 0.036523. So to find the price I'm willing to pay for the Verizon bond, so I'm assuming I'm willing to pay $990 for this bond, which gives me this yield. Well, I'm saying this yield to maturity on a taxable bond is the same thing as this yield to maturity on a tax exempt bond, which means when I say N is equal to 40, payment is equal to 30, future value is equal to 1,000. The yield to maturity is equal to 3.6523 divided by 2. Plug that in, press the present value key, that gives me the price of $1,331.13. Okay, so now let's go to number 4. In number 4, I want to I'll skip some of the math here, but I'll set it up for you every time. So in order to calculate the spot rates, I know that I'm willing to pay 97% of par. So let's do it off of $100. I'm willing to pay $97 to receive $100 in 6 months. And let's use Z1 here for the 6-month spot rate. So when I solve for Z1, I have 1 plus Z1 times 97 equals 100. I solve for Z1, and that's going to be 0.03093 or something along that line. I just wrote down, when you double it, and this is all I wrote down, when you double it, you get 6.186%. Okay, so now that I have Z1 is equal to this, I can say in a year I can pay $94 to get a T-bill that matures in a year, and it's going to pay me $0 in 6 months at a discount at 1.03. Let me get this exact number. I want to make sure I have that. Okay, so I did have that number exact, so 03093 to the first plus 100 plus 0 is a coupon over 1 plus Z2 squared. Now, of course, I don't have to deal with that because 0 divided by anything is 0. So 94 times 1 plus Z2 squared is equal to 100. So I can solve for Z2, and Z2 is equal to 0.03142, and so the 1 year spot rate is going to be twice that, which is 6.284%. Now all numbers come out of Excel, so they're rounded to the number of decimals you see here, so just keep in mind when you do this, to get my numbers you may want to go to one additional decimal place. So the important thing to notice right now, we're doing the calculations with the Z's, with the semi-annual rates, but when I talk about what's a 6-month spot rate, the 6-month spot rate I quote in annual terms. The 1 year spot rate I quote in annual terms. Okay, so now let's look at the next thing. Now that I know Z1 and Z2, I know that if I buy a bond that if I buy a bond that matures in a year and a half, I pay 98.5% of par. The price of any financial asset is the present value of expected future cash flows. The price of any financial asset is the present value of expected future cash flows. The price of this bond is $98.50. Its future cash flows are $3 because it's 6% coupon, pays semi-annually. 6% of 100 is 6, divided by 2, that's 3. So divide by 1.03093 to the first plus $3 over 1.03142 squared plus 103 over 1 plus Z3 cubed. So the price of any financial asset is the present value of expected future cash flows. With a bond, I know precisely what the cash flows are. So that's the size of the cash flows. The timing is represented by the 1, 2, and 3 because this comes in year 1, year 2, and year 3. The risk is embedded in the discount rate. So 6-month money is discounted at the 6-month spot rate. 1 year money is discounted at the 1 year spot rate. Year and a half money is discounted at the year and a half spot rate. All I have to do is algebraically solve for Z3. And I do that. Z3 is equal to 0.03548, so that means the year and a half spot rate, I don't say is 3.58%, 548%, I say it is equal to 7.097%. Alright, so I need to get the 2 year spot rate, so I find a 2 year bond, darker color, 2 year bond that sells for 100.5% par, $100.50. It has an 8% coupon, so it's going to pay me $4, $4, $4, and $104. So that's the size of the cash flow. It happens in year 1. So not year 1, time period 1, which is 6 months. 1 plus 0.03093 to the first, 1.03142 squared, 1.03548 cubed, 1 plus z4 to the fourth. Z4 is equal to 0.03896. So the 2-year spot rate is twice that, or 7.791%. So the key thing to think about here is, this is bootstrapping, so we find Z1 first. We got that. We can find Z2 because it's still a 0 coupon. Now once we go back out more than a year, you can't find 0 coupon instruments except for strips, which aren't liquid enough to really do this. So we go with the coupon pay bonds. So I know I'm willing to pay $98.50 to receive all 3. So think of this as 1, 2, 3 bonds. I know the value of bond 1 and bond 2 at 6 months and a year because I already know their discount rates. I just have to find the discount rate for a year and a half that makes this equation true. Once I do that, I know Z3. I can do the same thing for the 2-year. So now I know the following. Now I've determined Z1 is equal to, I'm just going to write these up again, 3.093%. I know Z2 is equal to 3.142%. I know Z3 is equal to 3.548%. I know Z4 is equal to 3.896%. Now I can price any bond that has 2 years to maturity. So the price of a bond that has 2 years to maturity and pays a coupon semi-annually of 7%. So it's going to be, and let me do this, I'll do this as $35. And we'll make par equal to 1,000. Doesn't matter, you can do 3.5 and 100, and it's just moving the decimal place. So if par was 1,000, assuming par is 1,000, that's the size of your cash flows. They occur at time period 1, 2, 3, and 4. So that's the timing of your cash flows. The risk is represented in the Z's that you found. 1.03142, 1.03548 to the third, 1.03896 to the fourth. Put all that in there, and the price of the bond is equal to 986.66. I hope that's the right number that I'm looking at. And then from that I can find the yield to maturity. So now I say n is equal to 4, the payment is equal to 35, the future value is equal to 1,000. So this is how someone would actually price a bond. They would be told, here's the payout rule that the issuer has given you, whoever the issuer is. You've determined what the spot rates are. Now, one aside here we didn't talk about. If this is we base this on a treasury. So if this is a risky bond like a Coke bond or Home Depot or somebody, I just add a risk premium. So to each of these I would add a risk premium. But we're not doing that, so don't worry about it. So now I discount those cash flows. I find the price is 986.66. I make that negative, plug it into my calculator, find IY, whatever that number comes out. The yield to maturity is 2 times this IY number, and that comes out to be 7.733%. I want you to notice another thing. If I have R1, R2, R3, and R4, so I'm stating the 6-month spot rate in annual terms is 6.186%. The 1-year spot rate is 6.284%. The year and a half spot rate is 7.097%, and the 2-year spot rate is 7.791%. What's this yield to maturity going to come out to be? It's going to be the average of these four numbers, but not the average like add up divided by 4 average. But when does the biggest cash flow come? The biggest cash flow comes here in year 4. So I know since the 2-year spot rate discounts most of the money, I know the yield to maturity is going to be close to the 2-year rate, and sure enough, it's right in between them, right? It's just a little bit less than the 2-year spot rate. So you can always know that yield is going to be some type of average, a weighted average, if you will, of these four numbers. And in a typical upward sloping yield curve, it's going to fall just below the 2-year spot rate. Okay, so let's see where we are with the problems. Okay, the answer is 5 now. Number 6, I want to find 1F1, the forward rate. So here's what I do. We're saying annual pay now to keep it a little bit easier. So the idea here is this. I have option A. Option A, I can invest for the entire 2 years at 4.5%. For the entire 2 years. I'll lock that up. I'm good. Option B, I can invest for 1 year at 4. And then I can invest after a year. I'll reinvest at a rate I don't know. 1F1 is a 1-period spot rate beginning in period 1. So this begins in period 1 and goes for 1 period. The forward rate here is what makes me indifferent between A and B. So let's make them equal to each other. 1.045, it's in there for 2 periods, is equal to 1.040, which is in there for 1 period, times 1 plus 1F1. That has to be there for 1 period as well, because 1 plus 1 is 2. I solve for this, and it comes out to be 5.002%. Okay, so let's look at what's the next one here. 2F1. This is a 2-period rate that begins in period 1. So we have a 3-period time horizon. This is a 2-period rate that begins in period 1. So option A is I invest at R1 and then reinvest at this rate I don't know. This one I don't know. Option B is I invest for the entire 3 periods at a rate I know. So the 3-year rate is 5.5, so I can invest at 5.5% for 3 periods, or I can invest at the 1-year spot rate for 1 period and then reinvest for 2 periods at some unknown rate. The forward rate is the rate that makes me indifferent. Note the 2 here matches the 2 there. Note that 1 plus 2 is equal to 3. You do all that, you know you have to set up correctly. Now it's just a math problem, just an algebra problem, and this should equal 6.258%. Okay, let's look at the next one, 1F2. So once again we have a 3-period time horizon. This is a 1-period rate that begins in period 2. 1-period rate that begins in period 2. So option A is to invest for 2 years at the 2-year spot rate option and then reinvest at this unknown rate. Option B is to invest for the full 3 years at the 3-year rate. The 3-year rate is 5.5%. Do that for 3 years. It's equal to 1.045. I can invest for 2 years at the 2-year rate and then reinvest at whatever the 1-year spot rate happens to be 2 years from now. So this is a 1 year spot rate 2 years from now, which I don't know, but that comes out to be 7.529%. I'm indifferent between option A and option B. Okay, I'm going to stop right there and make this part 1, and we'll do the next one part 2.